Hi, welcome to my video on transformations of a reflection in the x and y axes on y equals root x. And reflection in the y axis on the square root equation y equals root x. Let's see. Reflection in the y axis. That is denoted by the mapping rule. When you reflect in the y-axis, you're changing x to a negative x. You're not changing the y. So this equation here is going to be y equals root x. And the table of values for the basic equation, or for the square root function, is x is 0, x is 1, x is 4, x is 9. When you put a 0 in, you get a 0, square root of 0. Put a 1 in, square root of 1 is 1. Put a 4 in the place of x, square root of 4 is 2. Put a 9 in, the square root of 9 is 3. And I use this as my basic table, just sum of the values. Now, in the mapping rule, we change x to a negative x. So that means we'll make y equals x to a negative x. So what happens? X to a negative x, that means that let's go down here before I do this. The domain, let's plot this. 0, 0 is the vertex, or starting point I should say. 1, 1. X is 4, y is 2. X is 4, y is 2. And x is 9, y is 3. So this is the graph of the y equals root x, which is the basic equation of the square root. And there it is with these 4 points. And there's more because it just keeps going on and on. Now, the domain of this basic equation of the root, square root, the domain is x is greater than or equal to 0. And the range is y is greater than or equal to 0. Notice the x starts at 0 and goes to the right. And the y starts at 0 and goes up. And let's now look at y equals the square root of negative x, because we're changing x to a negative x when you reflect in the y-axis. So, reflect in the y-axis, the domain is x is greater than or equal to 0. So that means we have a negative x greater than or equal to 0. Divide by negative 1, and we have x is less than or equal to 0. Dividing an inequality by a negative number changes direction of the sign, greater than to a less than. So that means we have to look at the x's to a negative x. So 0, the negative of 0 is 0. The negative of 1 is negative 1. The negative of 4 is negative 4. The negative of 9 is negative 9. And again, just to emphasize that, we have the negative of 1, which is negative 1. The negative of 4, which is negative 4. And it's the negative of 9, which is negative 9. So notice the values of x, if you look at it this way, are starting as 0. And if x is 0, y is 0, because there's no such thing as negative of 0, because 0 is neither negative nor positive. So these are the values that we're subbing in. So notice in this mapping rule, x changed to negative x, but the y's are not changing. So these y values are not changing. So the y is 0, 1, 2, and 3. Well, let's look at, if you put a negative 1 in here, then you're going to get the negative of a negative 1, which is a plus 1. The square root of 1 is 1. If you put a negative 4 here, the negative of a negative 4 is a positive 4, which gives you 2. You put a negative 9, the negative of a negative 9 is 9, the square root of 9 is 3. So these are the table of values when you reflect the square root equation into the y-axis. So 0, 0, same point. X is negative 1, y is 1. X is negative 4, y is 2. X is negative 9, y is 3. So we have the reflection, and the y-axis is moving this way. And there's the points. Notice the x's have changed, but the y's haven't. The x's have changed to the opposite, but the y's kept the same values. So notice the y's are the same, but the x's are the opposite of each other. That means if we look at the x's, what the x's are, we worked it out. The x's are x is less than or equal to 0, but the y's are still, because the y's never change, so the y values are still greater than or equal to 0. The x's are starting at 0 and going to the left, so x is less than or equal to 0, but the y's are going up, so the y's are greater than or equal to 0. That's what happens when you reflect the y equals root x in the y-axis. Now let's reflect in the x-axis on y equals root x. And the mapping rule reflecting in the x-axis is that the y's will change. When you reflect in the x-axis, the y's are changing from positive to negative. So if this equation is y equals root x, again, that's the basic equation. The x's are 0, 1, 4, and 9. And the y values, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9, x is 9, square root of 9 is 3. And the table of values is, we see it here, this graph, 0, 0, x is 1, y is 1, x is 4, y is 2, x is 9, y is 3. Again, this is the graph of the basic function in terms of the square root. There's the graph, there's the table of values. The domain on this equation, the basic equation, y is greater than or equal to 0. Sorry, x is greater than or equal to 0 because the domain is the x. The range is y is greater than or equal to 0. Now, let's look at when you map. So x is not changed, but the y is changed to a negative. Y becomes negative y. So negative y equals root x. And when we have a negative y equals root x, because we change y to a negative y, we divide by negative 1, and we get y is equal to the negative of root x. And notice the x's are not changed, so 0, 1, 4, 9, the x values never change, but the y values are changing. So when we put 0 in, notice the y values are changing. So the opposite of 0 is still 0. The opposite of 1 is negative 1. The opposite of 2 is negative 2. The opposite of 3 is negative 3. But the y values are changing negative. And another way, if you put these values in for x, put x is 0, y is 0. X is 1, the square root of 1 is 1, negative 1. Put 4 in, square root of 4 is 2, negative 2. Put 9 in, square root of 9 is 3, negative 3. So, we got 0, 0, same starting point. When x is 1, y is negative 1. When x is 4, y is negative 2. When x is 9, y is negative 3. And so you can see that the x values didn't change, but the y values became opposites because it's reflected in the x-axis. So when you reflect in the x-axis, the y's change values, but not the x's. So notice the domain is still greater than or equal to 0 because the x has never changed, but the y is going down, so the y values is y less than or equal to 0. And the reason for that, right here, you have y greater than or equal to 0 in this equation. So now we have a negative y greater than or equal to 0 in this equation. And the negative y you divide by negative 1, so y is less than or equal to 0, which is what we have here. We can see from the graph. But when you put negative y is greater than or equal to 0 and solve it, then the y values become y is less than. Because you have a negative here, the y values in this equation will always be 0 and less. And that brings us, if you like my video, click on the like button and subscribe button and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's in the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.